Students, as I told, Francis turbine, the water flow in radial direction. So this is when it rotates, water is spills out in this direction, and in this direction the shaft is there. So this is the blade. This is rotate in that direction. These circumstances, this is direction, and this is this action. This will rotate from the center to radial direction. It will rotate here. Which which direction shaft is there, in that direction it will rotate. So that direction it will rotate, the axial direction it will rotate, and in the radial direction it will rotate. So these two turbine, either the axial direction, the Francis turbine, Kaplan turbine, axial direction, and the propeller turbine is the example for that one. The Kaplan turbine is the name itself, the science its name is Kaplan, who you find it, that one Kaplan turbine. And next, that impulse turbine pressure is constant, and reaction turbine the pressure is not constant. Here this turbine is inbuilt. You can see in your mobile some batteries inbuilt, in iPhone also inbuilt. So that in here also, this is in this turbine is inbuilt turbine. In that pipe inside only they are placing the turbines. So that's called inbuilt. You see, this is one turbine. Water is entering in this direction. Water is coming direction. The turbine is inbuilt. So water is passing in between that runner. So water is entering. P is equal to, for example, 5 bar here. So this is one direction. Velocity is here. They are placing 2 meter per second. Suppose that example. Outlet. If you consider outlet here, the section is that outlet section. P2 is that this component is already inbuilt inside the pipeline. So this is 2 bar, for example, and here velocity depends upon the cross section area. So V is equal to 1 meter per second. It's reduced actually. It depends on the cross section. The main components of the reaction turbine is inlet and an outlet pressure difference will get. Velocity also difference will get. So in that there is no tank in that outlet. In that impulse turbine we are showing, in it will that below one tank is there. Here there is no inlet tank is there. Velocity we also variation in this format will get. So the bottom tank is there. So the nozzle is connected here. So the runner is flowing here. The bracket is placed here. The bucket is placed here. So in this impulse turbine, what will happen? It's just comparison. The water strikes here. So it will starts to rotate, and water after strikes the water come down, and the water, all the drops water we are collecting in a small tank. And sometimes one box is provided. So from where it is comes, the dams. The dam, this is the reservoir or dam. So water is coming from that penstock pipes, and it strikes the runner, and the water drops and that collected from that higher elevation to lower elevation and strikes the here, and after collecting the water. This is called tail race. Tail race. Generally it's creating in higher around from that height head is 250 meter. Head is nothing but vertical height. If here we are considering water height, that's head. We can convert it head for pressure head. From that we know that pressure is equal to rho gh. So here the flow rate is flow rates controlling without loss. There is no losses in that. Here some losses is there. So water is entering in there from inlet, and water flow is controlling. Some water losses takes place. In that impulse turbine there is no water loss. So that is the difference between these two. So this tank, water is collecting from that. That height is called tail rise. The top of the surface is called. That runner is running and it's rotating, and then water is collecting from that tank. Then turbine is placed above the tail rise. but they here the inbuilt already. So this that this is called tail race. This that there's a mountain. The turbine is mounted inside the pipe, inside the water. So the turbine is immersed inside the water. So here that water strikes and the water is flowing. That here that all the water is flowing in that circumstances. The casing is provided here. Here casing. So so the turbine is placed inside the pipe. So that is covered. That is so that one pipe that is called casing. In that impulse turbine, we can see the working procedure, working turning procedure directly we can see. But here we can't see. If it is any damages happens in that turbine, reaction turbine, we can't see directly. We need to open the casing and we need to check the whether it's working proper or not. So if it is anything's happen, so here the pressure is maintaining and velocity is maintaining. So here sometimes the casing is providing because sometimes water is splash out from out of the out and so here in this if casing is provided means the water will not splash out. So so that reason sometimes the casing will provide for that one impulse turbine. So that is the one. And draft tube, what do you mean by draft tube? That we'll discuss. In Telton turbine, draft tube is not using generally. Draft tube will discuss. What do you mean by draft tube? Um, this is providing where water exits in generally in turbine. In that we are producing casing. So suppose here this is water is coming out from that one, and below in that one tank is they providing the tail race tank. So water is rotating in that circumstances in that runner, and after that it will come out from that outlet pipe. So that here that casing is provided here in the bottom. So this generally this here provided here. This is called draft tube. An outlet of the turbine we are providing. So where it is connected, it is top of the tail race. It's connected, tail race of the tank. So what happens? This tube itself we can see that variation of area, cross section area is totally changed. The starting the cross section area is less and it is generally gradually it's increased the area. So what happens though it's connected to the turbine when cross section it is gradually increasing, so it means decrease the velocity. So and maintain the velocity of the tank, what velocity of the top of the tank and velocity of the top of the surface of the water. So cross section of area of the pipe draft tube is increasing, it is decreasing the velocity, decreasing the velocity. If the tank is bigger, what is the velocity of the tank? If so the velocity is matching the top water what it's dropping, that velocity and that tail race the top of the water, that's two are matching. So the bottom of the cross section is big and the when it's connected in the top of the draft tube, that's small. So it's gradually reducing and it's matching that velocity of the tank water. So here that is kinetic energy loss is less. And the important point is when it is water entering here and it's turning out in the whole circumference of the pipe, so guide vanes is providing here. Guide means guidance, for guidance. So guide vanes is providing here. So when its water is entering, guide vanes is providing. So it means using that guide vanes, the water will rotating all the circumstances. Suppose the penstock is here and nozzle is connected. This is the turbine runner. This is the bucket is providing. It's when its water strikes, it started to rotate. Water strikes one bucket. First, it's initially starts one bucket. It will not. It's not completely covering the whole circumferences. So if we consider the compared to the Pelton turbine, reaction turbine will in that reaction turbine the whole circumferences water will rotate, but in that Pelton turbine the water will not rotate in the circumferences of the wheel tube. So this is the difference between that reaction turbine and impulse turbine. When liquid can the whole circumference, in that time liquid is not circulating whole circumferences. Here controlling the flow, there is no losses takes in impulse turbine. If you're controlling the flow also, here there is losses in reaction turbine. Losses takes place in reaction turbine. Francis turbine. If you have one tank, see this is the one turbine that is tank and it's connected to one turbine. The motor is connected. Motor is connected. This is one of the reaction turbine. Water is come out entering here. Water is come and it's entering here. When it's entering here, from the top of the tank water is allowing to go there turbine, and it's connecting to the turbine and it goes to the turbine. Water is entering inward. Water is from sometimes it's going inward and it goes to outward, outside direction, go to atmosphere pressure. So this is the pipeline, dotted pipeline what we are connecting, and the connected nozzle for that one. We increase the, it is converted the pressure energy to kinetic energy, and the water is flow come out in the atmospheric pressure. This direction also flow is there. The pipe is connected, the nozzle is connected, reverse direction also. When its water is entering here and it's trying to get into that two pipes, and after that water is come out from that nozzle. When this pressure energy entering to that, when pressure energy is converted to kinetic energy and it is come out within atmosphere pressure, where nozzle is started, that point is pressure energy is more. Velocities pressure energy is more in that time. It will increase, the kinetic energy will increase. So it means because of that pressure energy, here also the same concept it will work. So it's started to rotate in this direction. See this direction, the water is moving in radial direction, it will rotate like this way. Water is moving in rotate, it will start to rotate in this direction, start to rotate from this direction. This is the pipe, this is the pipe, this direction. Nozzle is connected. Inlet is pressure is more. Inlet is when water is entering, that inlet pressure is more. Outlet is not much pressure because it's an atmosphere pressure. So this is the in x direction, and different nozzle is connected, different pipe is connected. I think you clear. Now it started to rotate in this direction. So this is the one small diagram. This direction it will start to rotate, radially direction. This is called Francis turbine. This kind of Francis turbine, it starts to rotate this direction, radial direction it will. So that is called a radial flow turbine. So in that time the water is spills out from radial direction. So from the inside the water is come out. So water is circulating the whole circumferences. So its water is going inside to outside direction. It So it is exit pressure is atmosphere pressure. When water is come out from then it is atmosphere pressure. It's depend on that the rotation is depends on how much water how heighted water you are stored. They depend on that one. That in the edge of the nozzle, the lot of more pressure energy is there. P1 is atmosphere. P2 is the P1 is the atmosphere pressure. P2 is the pipe pressure. When it starts to rotate, it started to rotate. I hope you understand what is the difference between impulse turbine and reaction turbine.